lesson 7.4, and we're looking at special products. What that means is that, remember in our last lesson we were multiplying polynomials together, but some polynomial multiplications have special patterns to them, and that's what we're going to be taking a look at today. We'll use those patterns to help us multiply quickly. So the first pattern is the sum and difference pattern. And what that means is that one polynomial will be the sum of two terms, and the other is the difference of those same two terms. And so what does that look like if we multiply those together? Right? We're going to multiply it in our standard way. I'm going to use the distributive property. So a times a squared. And then we'll do a times negative b. That's negative ab. All right, now we multiply the b in the first term, in the first polynomial, times each of the terms in the second. B times a, and both are positive, so plus ab. And then finally, positive b times negative b is negative b squared. So whenever polynomials have this pattern, this is what their product would look like. Of course, there'll be different values where the a is and where the b is, but this is essentially the pattern. And the interesting thing about this pattern is if you look at the two like terms here, they are opposite signs, and so that means they add up to 0. Therefore, these two terms will always vanish whenever we do this special product, and we end up with the first term a squared and the last term, which is minus b squared. And so this pattern will always result in this appearance: the first term squared minus the second term squared. Every single time those two middle terms are going to be eliminated. Okay, so that's what we're going to do, is use this pattern to actually multiply these out instead of doing it the long ways. Now, there's nothing wrong with doing all of the distribution. So if you don't learn this pattern, you always have the distributive property or the box method to help you multiply this out. But it would be really helpful to learn the pattern so that you can quickly multiply this. Now, you should recognize that this is a sum and difference pattern. The first polynomial is the sum of x plus 3, and the second one is the difference of x and 3. So therefore, when I multiply, I'm simply going to take the first term, remember. So I take the first term, which is a, and then I square it. So my first term is x, and I'm going to square that. So x squared. All right, the second part of the pattern is I'm going to do subtraction, so I write minus. And the third part of the pattern is the second term gets squared. So I take the b and I square it. Well, my b is a 3, so I write 3 squared. And so this is the product of those two binomials. Of course, I'm going to want to write 3 squared as 9, so this finally results in x squared minus 9. All right, so using this sum and difference pattern, let's do it on this one. Again, this is a sum and difference. We just have the difference first. That doesn't matter. All right, so this would result in, we take the first term and square it, x squared. And then we take we always do minus, and then we take the second term and square it, 7 times 7, which is 49. All right, see how fast that is? All right, verify that you have a sum and difference pattern first. 3x minus 1, that's the difference. 3x plus 1, that's the sum. All right, so we're ready to go. We take the first term and square it, so 3x squared. You're squaring the 3 and the x, so you can do that in your head with mental math maybe, but I want you to recognize that the entire term is squared, not just the x. Okay? All right, then the next part of the pattern is the minus sign. And then the last part of the pattern is 1 squared, 1 times 1. All right, so let's just write that out. 3x, quantity squared, that's 3 times 3, 9, x squared. So our exponential rule says that we square everything inside the parentheses, and then minus 1 squared, minus 1. Okay? All right, now there are two more patterns to show you. All right, this is the square of a sum, and this one is the square of a difference. You do want to remember that when I'm squaring something, that means I'm multiplying it by itself. So this is a plus b times a plus b. So I'm just going to do it the long ways first, and so that you can see how the pattern happens. So a times a, and then a times b. So the result is a squared plus b squared. Oh, a squared. And then the second term would be a times b, which is ab. All right, now I'm going to do multiplication by the second term. B times a, which is ab, and then b times b, which is b squared. All right, so my sum and difference pattern, you can see that the two middle terms are identical. Remember, in the sum and difference pattern, they were opposites. Here they're identical, and this is going to happen every time. They'll both be positive a times b. So recognizing that pattern, I'm going to just write the final form. It would always look like this: a squared plus 2ab plus b squared. All right, up here, the way I think of it is I look at this, I remember this pattern by remembering that I have to square the a term, I have to square the b term, and then I have to multiply these two together, a times b, but I have to do it twice. And that's what gives me the 2ab. All right, so let's try it on one of these down here. X plus 3, quantity squared. So the pattern is I square the first term, I square the last term, 3 squared, so that's going to go on the end. And the middle term, so since it's positive, I know it'll be plus, positive. I'm going to multiply these two together, 3x, but I have to do it twice. So it's going to be 2 times 3x. So that's 6x. And this is my product, without having to do a box or all of the distributive property. Let's try it one more time on part C. Okay, so once again, the pattern, it's a binomial squared. Sum of, and it's a sum, so we're going to do y squared, 1 squared, which is 1, and then we multiply these together. That's 1 times y, and then I have to do it again, y times 1, so that's 2 of those, 2y. And this is my answer. I do want you to recognize that we end up with this middle term here. I often see students just square the ends and say, okay, there's the answer. You got to be careful. There's a middle term. There should be 3 in your answer when you do this. All right? So that's unlike the sum and difference pattern, and the reason we don't end up with that middle term is because they're opposite in signs when we do the product. This one, we did not get opposite signs. We ended up with same sign. That's why we end up with the middle term. All right, so I'm wondering if you can guess what this pattern will look like. So let's multiply it out. Okay, so I'm going to expand it first. This is a minus b times a minus b, and then multiply it out, a times a squared. Okay, this product here will give me negative a times b. Now multiply by the b. That's a negative b times positive a, again another negative ab. And then the last one is a negative b times a negative b, which is a positive b squared. So the final result is, here are like terms. We combine those together. We have 2 of them. So negative 1 and negative 1 make negative 2 ab. And these other terms just come down. And so this is my pattern. They look almost identical, right? It's just that one is a plus and one is a minus. And you'll know that, notice that this one is a sum and this one is a difference. All right, so let's see if we can apply the pattern with this example. So again, we take the first term and we square it. So this one gets squared. The last term, so the b, is squared, and notice it's a sum. It's always going to be a sum, even though this is negative. And the reason is that we're doing negative b times negative b. So that's a positive b squared. So this negative 3, when we square it, gives us positive 9. All right, now the middle term. We multiply these together, negative 3 times x, and then we have to double it. We have to do it again, so 2 times that. That's negative 6x. All right, that's our answer. Let's do it again. One more time. Okay, so we're going to square this term. That's 2z, quantity squared. So 2z times 2z. All right, that's our first term. Okay, the last term. Again, oh, it's minus 3 again. I should put a different number. But anyway, minus 3 squared. So that's going to be plus 9. All right, the middle term. Multiply these together. What's negative 3 times 2z? I can write that out. Negative 3 times 2z. All right, multiply together. But then we have to do it again. When we do the distributive property, we do it again. So there's 2 of those. All right, so this middle term is this product. This is negative 6z times 2, negative 12z. All right, so this is equal to 4z squared minus 12z plus 9. And that's all there is to it. All right, time for you to go to section 7.4 and do the practice.